And I want to begin, if you want to type in your question into the chat while I'm speaking, you can do that. Leanne, I saw yours and I'll address it in just a minute. Or in a few moments, I'll give you the opportunity and you can unmute and speak. But I want to start with kind of a general overview of the final exam, not knowing whether or not you all have had the opportunity or taken the opportunity to look at it. So I am going to share my screen so you can see what I'm looking at. This document was in the announcements, I believe, under week 7. And it gives you some general information about the final exam. First of all, the final exam for Math 1401 is not proctored, which means you do not have to use Respondus Lockdown Browser. You can use any handwritten notes, the flowcharts, the PowerPoints, the practice problems, or the homework problems that you've had access to within the course during the final exam. You also need to access and will have to use Minitab during the final exam. I do not have the Minitab output results embedded in the questions for the final as they were for the midterm. Okay, so you'll have to actually type the data in and run the Minitab for the final exam. The final exam does open on Tuesday, July 27th. And will close on Saturday, July 31st at 11:30 p.m. You are allotted 2 hours, so you'll need at least a 2-hour uninterrupted time period to take the final exam. You only have one attempt and there are no makeups for the final exam. I would caution you, some of the students in my face-to-face class have commented that Minitab told them that your access would end on Friday, July the 30th. My understanding is that it ends on the 31st. So I would be leery of waiting until the last minute to take the final exam. It is formatted very similarly to the midterm. It has multiple choice questions as well as fill in the blank questions where you type in the answer. The biggest issue that many students have is that they fail to include the appropriate number of decimal places. They either put too few or too many, and D2L does count those wrong. However, remember that I do review each individual final exam for such errors and can award credit as needed, but it's helpful if you follow the instructions. The final exam focuses primarily on the content. In fact, all of it is on modules 3 and 4. And then I give you kind of a breakdown of the questions you should expect. The first 2 sections are related to confidence intervals, which come from module 3. Then you have sections 3 and 4 are related to the one mean hypothesis test. I would anticipate that one of those is a Z, as in zebra test, and the other is a T, as in tiger test. Sections 5 and 6 deal with chi-square goodness of fit. You have one question where you have equal proportions, and then a second one where you have specific proportions. Section 7 is analysis of variance, and then section 8 is correlation and regression. So you can kind of add those numbers up there and get a sense of how many questions you have. Let's see, 35 and 16 would be 51, about 62 questions. The final exam itself is worth 150 points. It's 2.38095 points each per question. Okay, so I'm going to pause for a minute, and I've heard a few others come into the room. That's just very general information about the final exam. This document is posted in D2L. I believe, if I remember correctly, it's under week 7. I can double check that. Yes, it was attached to the week 7 announcement so that you can view it yourself or print it out as you so desire. But are there any in general type questions related to the final exam before we get into specific content? Okay, the other thing that I sent you, and I can address questions to that. From that, I can address questions from your homework, from your practice problems. Again, focusing primarily on modules 3 and 4. Leanne came into the room and I had her type her questions. And one of the questions that she asked in the chat is, some of the example questions on the review were t-test, right? Because the standard deviation was not given. So that review was posted to the announcement about this session. And let me see, I'm going to scan through, but I'm pretty sure you're correct. Okay, if you look at the review sheet, when you get to questions 33 through 40, questions 33 through 40 would be a 1 mean Z as in zebra, because, and let me share my screen so you guys can see it. Sorry, I forget to do that. Okay, I'm looking at the review sheet that was attached to the announcement about this review session. And again, if you look at questions 33 through 40, because the question clearly states the population standard deviation, this would be a 1 mean Z test. Okay, that's how you make the determination about whether it's a Z or a T. Okay, so let me scroll on down. When you get to question 41, again, it gives you a population standard deviation. Okay, so again, that's going to be a 1 mean Z test, because you know the population standard deviation. Okay, then we go to the next one. Okay, then when we get to the next one, this one actually is a t-test, and it's a t-test where you've been given the raw data. And I recognize that it's a T, okay, because nowhere in this story or in this scenario does it give me the population standard deviation. But when I put in this data that I'm given, I can find the sample standard deviation. So this would be a 1 mean, and I'm going to capitalize it, T test. And again, in this particular example, you have the raw data. And it does not include the population standard deviation. Okay, then let me scroll on down. Same thing with the next scenario. Again, you have raw data, and it does not give you anywhere in this scenario, it doesn't give you the population standard deviation. So this again would be a 1 mean T test. And again, you have the raw data. And then let me scroll down. Okay, the next one gets into chi-square goodness of fit. So hopefully that addresses one of your questions, Leanne. The other one that you ask is going to be a little bit more challenging to answer, because The question is, what is the correct conclusion format we should write for a z-test or a t-test? First of all, those questions, if I remember correctly, on the final are multiple choice. The format in which they're written depends upon the conclusion, whether you reject the null hypothesis or fail to reject the null hypothesis. It depends upon the whole scenario, because the conclusion is kind of the culmination of that. And so it's kind of difficult to answer that question, because it's not necessarily the same from question to question. There's not a nice, neat little formulaic conclusion that you can write. It's a critical thinking thought process. Now I can work through an example of either a Z or a T if you would like, and try to address that question. Do you want me to start there since you asked the first question, and then I'll open the floor up for the others of you?
Yes, ma'am, I would like that, please.
Okay, can I use one of the ones that's on the review sheet that we were just looking at?
Absolutely.
Okay. All right, so I'm going to share my screen again, and I'm going back to the review sheet that was attached to the announcement about this review session. And I'm going to start with the question right above numbers 33 through 40, because we already decided that was a one mean z-test. So the scenario reads, a recent study found that the mean time spent per visit to Facebook was 20 minutes. Assume the population standard deviation is 8 minutes. Suppose you have a sample, or suppose you sample 100 Georgia Highlands College students and determine the sample mean is 24.5 minutes. A sociologist is interested in knowing whether the mean time per visit to Facebook has decreased. Conduct a hypothesis test using a 5% level of significance to determine if the mean time per visit to Facebook has decreased. The first question asks you whether you should do a Z or a T. Again, we're going to do Z as in zebra, because we are given the population standard deviation. And guys, if I remember correctly, these are the type questions you're going to see on the exam in this order, okay? Because this is a process, and it really has to be in this order. So then the second step is to state the hypothesis. And I know initially that a number of you struggled with stating the hypothesis. Because I wrote most of the questions, I can tell you that oftentimes the hypothesis is stated or possibly restated near the end of the question. And you want to look for words like claim, believe, think, conclude. This particular one is reasonably straightforward, because the last sentence says conduct. It's telling you to conduct a hypothesis test to determine if the mean time per visit to Facebook has decreased, and it's decreased from what was found in the recent study, which was 20 minutes. Now you have to kind of put that together, but the claim that we want to use is the mean time per visit to Facebook has decreased. I hope you realize that the word decrease would imply less than from a mathematical standpoint. If it's decreased, it's gotten smaller, or less than. Because this is less than and in no way implies equal, This statement that I have highlighted in green is my alternative hypothesis. So my alternative hypothesis is going to be that the mean is less or has decreased from the 20 minutes that the study had found. Since my alternative is less than, the null would be that the mean is greater than or equal to 20 minutes. Couple of things to remember. The null hypothesis must always contain equal in some format. Guys, it's multiple choice on the final. If nothing else, you should get the null hypothesis right. It's got to have the equal in it. Okay, so there's our hypothesis. Then we identify all of the information from the problem, from the scenario. In the scenario, we need, to conduct the problem, we need our population mean, which comes from the hypothesis. So that's 20. The population standard deviation is given, I have it highlighted in yellow, it's 8. I need the sample mean, and in about the third sentence it says very clearly, the sample mean is 24.5 minutes. Guys, don't overthink it. It's usually clearly stated for you, 24.5. It tells us earlier in that same sentence that we sampled 100 Georgia Highlands College students. So my sample size is 100. And finally, we have our significance level, and it tells us to use 5%. Now, we usually prefer to have that written as a decimal. So my level of significance is 5%, or as a decimal is 0.05. If you don't remember how to get there, remember you do 5 divided by 100 and do the division on your calculator. Then this asks, and I don't remember if this is one of the questions that we talked about, but it asks, is it a one-tailed or a two-tailed test? It is a one-tailed test because it is less than. To decide the type of test, whether it's one-tailed or two-tailed, you always look at the alternative hypothesis. If it's less than or greater than, it's a one-tail. It's only a two-tail when it's not equal. So this one would be a one-tailed test. And I don't think that's something that I ask you anymore, because I don't necessarily need to know that for Minitab. But this is a one-tailed test. Then it asks, what is the test statistic and the corresponding p-value? To answer those two questions, we go out to Minitab. Okay, so I'm going over to Minitab, and let me write down my numbers real quick so I'll have them. Population mean is 20, standard deviation is 8, sample mean is 24.5, N is 100, we're doing 0.05, and it's a less than. Okay, so I'm in Minitab. In Minitab, we go to Stat, Basic Statistics, 1 sample Z. Guys, I can see that you're chatting, but I don't know what you're saying. Could I scroll down? I think okay, I'm still screen sharing, but let me stop the share and try it again. If you're still having issues, you may need to log out and log back in. Okay, so I'm going back to screen share. Okay, you should be seeing my Minitab screen. Are you guys seeing the Minitab screen?
Good, my way. Yes, it was the other screen that I was
Okay.
unable to see, Miss
Okay.
Ross.
Yes, ma'am.
I'll go back to it in just a minute so that you can get that information. So hold on. Okay. So we're in mini tab. We're going to stat, basic statistics, one sample Z, because we decided we were doing a Z test. Do you have one or more samples each in a column? I do not. I have summarized data, which is what we typically use. Summarized data. It asked me for the sample size, which was 100. It asked me for the sample mean, which was 24.5. The known standard deviation. Minitab calls the population standard deviation the known standard deviation, which is 8. I do want to perform a hypothesis test. My hypothesized mean, or the population mean, is 20. I click on options. I had a 5% significance level, so I have a 95% confidence level. And then I have to choose the right symbol that's in my hypothesis, which was the less than. I tell it okay, okay. And then I get the Z under test. I get the Z value is 5.63 and the P value is 1. Something ain't jihad. Hold on just a minute. That sounds just a little bit outrageous. Let me double check I put my numbers in right. Sample size is 100. Sample mean was 24.5. Standard deviation was 8. Hypothesized mean is 20. We're doing 95%, and we're saying that it decreased. Nope, we got all the numbers in there right. That's pretty wonky, but it is the answer. I double checked the numbers. And guys, you may want to double check yourself when you're taking it. Okay. All right. So my test statistic, going back to this sheet, can you guys see the sheet of paper now? Some of you were having trouble seeing it.
Yes.
Yes, ma'am.
All right. So my Z from Minitab is 5.63 and my p-value is 1. Then I need to make a decision based on the statement, and I've got to compare that p-value to the alpha. So my p-value from Minitab is 1. Alpha is 0.05. I always tell students to make this comparison digit for digit. So if we compare the first number in front of the decimal, we have 1 compared to 0. 1 is greater than 0, therefore P is greater than 0. When P is greater than alpha, we always fail to reject the null. And I believe on the final, it'll say you fail to reject the null because P is greater than alpha. That's the why. And Leanne, this is the part that you asked me about. Okay, so I got to think this through. It's a thinking through process. If I fail to reject the null, if I go back up here to the top, what that means, because I have failed to reject the null, that means that this null statement is true and the alternative is false. And you should always state your conclusion in terms of the statement that is true. So we were trying to prove that the mean time per visit to Facebook has decreased. But the statement that we proved to be true is that it's greater than or equal to that. Okay, so the easiest way to do it is to do this, is to write it this way. You always should include your significance level. So I'm going to say at the 5% level of significance. And I usually begin my conclusion with that level of significance. It should always be included. Okay. And then I'm going to copy this green statement, the one I have highlighted in green. The mean time per visit to Facebook has, but I'm going to add a word. The mean time per Facebook visit has not decreased from 20 minutes. I add the word not, okay? I can use the same statement that I had for my hypothesis, but I have to alter it to show that what I proved or what we verified was that it is greater than or equal to 20, not less than or decreased. It's actually increased. So I add that one 3-letter word, not, into the statement. And oftentimes that's the easiest way to write your conclusion, is to use the original hypothesis and word it in such a way, if you need to add a word like not, so that it is stated in terms of the true hypothesis. Now, there's other ways to say that. We could have said the mean time per Facebook visit has increased. I mean, that's what not decreased implies. So you could have said has increased. So there's different ways to word it. So I know that those questions on the final are multiple choice. I think you get 2 choices. So it's going to be a lot more of think through the process. It's not, I can't just give you one pat answer for that.
Yes, ma'am. Thank you for going through that.
You're welcome. All right, let me see if I can look at the chat real quick. Okay, I don't see any other questions in the chat other than some of you were having trouble with the screen sharing. Have you all been able to see it now? All right. Do you have other questions? You're welcome to type them into the chat, or you can unmute yourself and speak. I'm sure there's...
going in, sorry.
Go ahead.
Are you going in like a specific order or?
No, ma'am. I'm just answering questions. So do you have one?
I do. Have you been over the linear line correlation?
No, ma'am. I have not discussed correlation and regression.
Okay. Well, this was the one that I had the hardest time out of the whole class.
Okay. Let me go. I'm going to use the one that's here on this review sheet. And for Runji, I see your question about a t-test, and I'll come back to that, okay? Just hang in there for a minute.
Okay.
All right. I'm on this review sheet, and it's going to be the questions right above questions 82 and 83. And it says the following table is the number of stories and heights of buildings for a city. And you have the stories are in the left-hand column and the heights are in the right-hand column. First of all, you may have to recognize, oh, this is correlation and regression. The way you recognize that it's correlation and regression is that you have 2 pieces of data. All of the other data sets, we've had 1 variable, okay? In this case, we have 2 variables. We have stories, the number of stories, or floors, and then the height. So we have to decide which role each variable is going to play. You have the independent variable and you have the dependent variable. The independent variable is the value that you can control or manipulate. It's the one that you're able to change. Think about it from an algebra standpoint. In algebra, normally we would choose the x variable to substitute into an equation. So the x variable is your independent. And in this scenario, the variable that we're able to control is the number of stories in the building. And typically, again, this is kind of a standard across the board, so that whether we're in Georgia or Japan or England, everybody reads it the same way. Typically, your independent is in the left column. That's the standard. So the independent variable here is the number of stories. The dependent variable then, which is determined by the number of stories, the height depends on the number of stories. So the y, or the dependent, is your height. And again, in most cases, and again, because I wrote the questions, I know it's this way. The left-hand column is the independent, and the dependent is in the right-hand column. That is the standard, so that everybody, regardless of where they are, read it the same way. So the dependent here is your height. Now, I gave you on this piece of paper, or on this document, I gave you the scatter plot. You may have to create your own scatter plot in Minitab, and I'll go through that in just a minute. But once you decide which variable is the x and which variable is the y, ultimately your goal is to answer the question, is there a relationship between the number of stories and heights? Okay. Is there a relationship between the number of stories and the heights of building for a particular city? And we begin to try to answer that question, is there a relationship? And we initially look at it with our eyeballs from a visual perspective, and you may throw in a little bit of gut instinct. And so you create the scatter plot if it's not given to you, and it's given here, and I'll show you how to create it in just a minute. And then after you get the scatter plot, you want to kind of take a step back, because you want to be able to look at the whole picture. You don't want to just zero in on one specific point. You want to look at the big picture. And you think about 3 questions. Does there appear to be a pattern within these data points? Well, I'm looking at these data points and I'm thinking, yeah, there is kind of a pattern. So I'm going to say, yes, I think there's a pattern. For our purposes, we have the second question. Does the overall pattern appear to be linear? In other words, could you imagine drawing a line through some of these points, kind of middle of the road on that graph? Now, in this course, we are only considering whether the pattern is linear. That doesn't mean there can't be other patterns. There are, okay? But for our purposes, we only look at linear. So again, in my mind, I'm thinking, yeah, I think there's a linear pattern there. And then we ask ourselves, does that pattern appear to be positive, negative, or 0? And this question actually relates back to something you learned in algebra called the slope or the tilt of the line. And this is going to be important a little bit later. So if I'm looking at my graph it appears as the number of stories goes up, the height goes up, which makes sense. And so my line appears to go up as I move left to right, which implies that the pattern is positive. Well, that's all well, good, and fine. But again, I've based it on my eyeballs and my gut. And honestly, we could have a disagreement. Leanne could have said, well, Miss Rawson, I don't think there's a pattern in those dots. Or Farunja could have said, well, I don't think the pattern's linear. Okay, so we could have a disagreement because different people may look at that graph and interpret it differently. So then we get to the next question, and in the next question, as you move to use a calculator to determine the linear correlation coefficient, we're now going to look at it from an algebraic standpoint. We're going to do the algebra. We're going to do the math. And we're going to calculate this linear correlation coefficient, which is a numerical measurement of the strength and the direction of our correlation. It's going to give us a number. Now, a couple of things that you guys may have overlooked in some of the notes. When you calculate this R, it's always between -1 and +1. Okay, now you're using the computer to do that, but you should always get a value between -1 and +1. Let me go over to a clean sheet of paper for a minute, because this looks like you have to kind of think about this as a thermometer. Okay, if you have a linear correlation value of -1, that means you have a perfect negative linear correlation. And visually, if you have this picture, you would literally have your data values lined up in a perfect line, and they would appear to go down as you move left to right. On the other extreme, at +1, you would have a perfect positive linear correlation. And again, visually what you would have is you would have your data values lined up one right after the other in a perfectly straight line, going up as you move left to right. Now in the middle, of course, between -1 and 1 is 0. If your R value is 0, that means there is no linear correlation at all. And visually, that could be one of two things. If you have an R value that's close to 0, it might be that there's just no rhyme or reason to the dots. It's just a bunch of random dots all over the place. Looks like paint splatter. Okay, and there's no rhyme or reason to it. The other possibility is that you do have a pattern within the dots, but that pattern is not linear. And you treat this like a thermometer. As you move away from 0 toward +1, this would be like weak to strong. Some of you are having trouble with that. Moderate's kind of in the middle. And it works the same way if you go in the negative direction. It's just a matter of whether it's a positive relationship or negative relationship. So again, as you move away from 0 in the negative direction, you move from weak, negative, to strong, and again, moderate's in the middle. Now, there's no set numbers to say, okay, at this point, we go from being weak to being moderate, or from this point, we go from moderate to strong. Okay, it's kind of your own interpretation. But if you want some guidelines, okay, just for example's sake, probably till you're about, say, at about 3/10, maybe 4/10, you're weak. And then moderate maybe takes you up to about 0.7, and then from 0.7 up, you're strong. And again, those are not set in stone. I mean, I could say, well, we're going to do -0.4 and, -0.8 on the other side. I mean, it's your gut instinct, okay? The biggest thing is to think about where there is positive or negative. Okay, so hopefully that'll help you for some of you that were having trouble. But we're going to do the math. Well, to do the math, we need Minitab. Okay, so we use Minitab to calculate R. We're also, at the same time, I'm going to show you how to create the scatter plot, because I don't think it does it for you on the final, and you'll have to create one. To do that, I need the data. So I've got to scroll back up, and I'm going to scribble down my data real quick. Okay, so I can take it over to Minitab. The biggest thing here is when you're transferring this, two things. One, make sure you get the numbers written down right. Two, especially with this data where they're in pairs, you want to keep them paired in the way that they're given to you. Don't mix the pairs up. They have to stay paired the way that they're given. Okay, so I've got that written down. I'm going over to Minitab, and I'm going to enter the data. So in column 1, I'm going to put the number of stories, and that's my X variable. And I'm going to go ahead and type those in: 35, 55, 65, 25, 67, and 23. Then in column 2, right next to it, I'm going to put the height in feet, which is Y. And again, I'm keeping them paired up just the way that they were given to me. Okay, so I got all the numbers in. I'm going to do the scatter plot first. The scatter plot is a graph. So we go to Graph, Scatter Plot. We're going to keep it simple. Now be careful, because notice Minitab is backwards for whatever reason. It asks you for the Y variable first. The Y variable is the height. The X variable is in column 1. And I tell it okay. And I don't have to get fancy and put a title and all that. I just need to be able to look at the picture. And so here's the scatter plot, which looks like the one I had on the paper. Okay, I'm going to walk through that one more time, because you will have to probably do that for yourself on the test. Again, we're doing a scatter plot. It's a graph called a scatter plot. We keep it simple. Again, caution, caution, caution. It says Y variable is on the left, which is backwards to what we think. Again, that's my feet. Then my X variable is the number of stories. And I click OK. And it gives me the picture. Now, moving on, I need to calculate the linear correlation coefficient. And there's several ways to do this. And I know some of you were struggling with it, especially in terms of the R and the R squared. So I'm going to show you maybe what's an easier way than what you've been doing. Okay. We go to Stat, Basic Statistics, Correlation. That's a new path. Stat, Basic Statistics, Correlation. it asked me, what two things do you want to relate? I want to relate the number of stories to the height. Choose them both, and I click OK. Let me get to where I can scroll this up. Okay, so up here on the top, you got to find it. Okay, when you get your results, it gives you the scatter plot again. Okay, right under the scatter plot, notice right here under the scatter plot, R equals 0.909. Okay, so if you use that path, it gives you both. It gives you the scatter plot and the R value at the same time. Okay, so you can do that if you want. Stat, basic statistics, correlation. Does somebody have a question?
No, you just redid it for me again.
Okay, you got it?
Yeah, thank you.
Okay, so it gives you the scatter plot and the R value. The R value is directly under the scatter plot, right above the horizontal number line. Everybody see it? R equals 0.909. Okay, so I'm going back to my paper. And so I'm going to write down my R value. Okay, and again, that's like, okay, great, I've got my R value. But then we have to decide, is R statistically significant? Is it, in a sense, close enough to 0 or excuse me, close enough to 1 or far enough away from 0 that we can say without a doubt, yes, there is a relationship? So we have to conduct a hypothesis test on the R value. And that's what I'm going to be doing in question 86. The hypotheses for this test are the same every time, all the time. When you're testing whether R is statistically significant or not, your hypotheses are the same every time, all the time. We say that rho, which is the population correlation coefficient, equals 0 or rho does not equal 0. Now I'm going to write off to the side what that means, because you got to know what it means. If rho equals 0, that means there is not a linear relationship and R is not statistically significant. The alternative hypothesis means if rho is not equal to 0, it means there is a linear relationship and R is statistically significant. But in terms of how the question's worded on the final, when you're asked to state the hypothesis in this context, this is the notation you want to look for. Okay, so I'm going to pause there for just a minute. And then I've got to go out back to Minitab because I need the p-value of the test statistic so I can make a decision about whether to reject or fail to reject, which ultimately determines whether I have a relationship or not. So I'm going back out to Minitab. And we're going to go Stat, Regression, Regression, Fit Regression Model. Stat, Regression, Regression, Fit Regression Model. Okay, then it asked me for the response variable. The response variable is always the Y. The response variable is always the Y. Then we have to choose the continuous predictor. The continuous predictor is always the X. The continuous predictor is always the X. Once I have my variable selected, I tell it OK. And I get lots and lots of information. Okay. The value that I need, the p-value that I need, is here on the, it's at the very bottom under the analysis of variance, under the header, p-value. My p-value is 0.012. Okay. Now again, when you get this printout or when the results appear, you get lots of stuff. You have to scroll to the bottom to the analysis of variance header and then get the p-value. So I'm going back to my paper so I can write it down. My p-value is 0.012. Then it says, using alpha equals 0.05, make a decision. So again, we're going to compare p to alpha. P is 0.012. Alpha is 0.05. Again, the easiest way to do that, guys, is to do digit for digit. So the first number after the decimal, 0 compared to 0 is the same. Second digit, 1 compared to 5. 1 is less than 5. So P is less than or equal to alpha. When P is less than or equal to alpha, we reject the null. If I reject the null, that means the null hypothesis is false and the alternative is true. In this case, if the alternative is true, which it is, that means there is a linear correlate or linear relationship and R is statistically significant. And so question D here says, is the linear correlation coefficient R statistically significant? Because the alternative is true, we say yes, R is statistically significant. And then the follow-up question says, is there a linear correlation between the number of stories and the height of the building? Yes, because the null hypothesis is, the alternative hypothesis is true, which means there is a linear relationship and R is statistically significant. Now, let me point out one thing. Guys, these two questions, the D and question 87, have to have the same answer. If you tell me that R is statistically significant, that means there is a linear relationship. So you have to say, yes, R is statistically significant, and yes, there is a linear relationship. It's also true on the flip side. If you say, no, R is not statistically significant, then you have to say, no, there is not a linear relationship. They have to match. Those two statements, R is statistically significant and there is a linear relationship, mean the same thing. They're just worded differently. All right, so then this says using your calculator, okay, but we're not using the calculator, we're using Minitab. Okay, so I got a little typo there. Determine the line of best fit. Okay, because you have said, yes, R statistically significant, and yes, there is a correlation, that means you can find this line of best fit or find the model. And guys, this format is just a lettering deal, but we're writing the equation of a line, and from algebra, you would have thought mx plus b, where m is the slope and b is the y-intercept. Okay, they changed the notation for statistics. It's not a big deal. But Minitab has done that for you. In the command that we just ran, when we went stat, regression, regression, fit regression model to get the p-value, it also gave us, at the very beginning, my regression equation. It is clearly labeled regression equation. Now you have to write it in terms of the y and the x. Because notice what I did. When I labeled my columns, I labeled it y and x accordingly so that I can see that my equation is going to be y equals 332.7 plus 4.139x. Okay, I'm going back to the paper. So my line of best fit, or the model based on the data that we have, is y, or y hat, that shows it's a model, equals 332.7 plus 4.139x. X represents the number of stories the building has, and y hat is the height. Your X and Y, that's what we would define them as to start with. There's your model. The other issue some of you are having is making a prediction. Guys, if you got a model, if you've decided, yes, R is statistically significant, and yes, there is a linear correlation, that means you can find the model. Once you find the model, you use it. If you can't find the model, you can't use it. So if you've said, no, R is not statistically significant, and no, there is not a linear relationship, you ain't going to be finding no model. And if you ain't got a model, you can't make a prediction. Okay, so the next question says, predict the average height of a building if there are 50 stories. Guys, this is your predicting value. This is the value for X, and they want you to predict on that value. This is your predicted value. Yes?
So I think this is where I was having trouble at, for the X. Well, we will use the same equation for number 88 and put the 50 next to. Okay.
Exactly what you're going to do. You got the model. That's the model that we found in question 88. Now in question 89, they're saying, okay, let's make a prediction using this model. And guys, that's what they do in the real world. You know, this was talking about the number of stories and the height of a building, but it could be, you know, the amount of advertising compared to the amount of sales. And they could predict, well, if I spend this much on advertising, how much sales could I expect? It's a straight, y'all are overthinking it. It's a straight flat out algebra problem where you plug it in, plug it in. So I'm going to do y hat equals 332.7 plus 4.139 times the 50, and I got the 50 because that's what was given to me. Guys, the predicted value that they want you to plug into the model will be given to you. Now, in one of the videos, the instructor that was making that video, she just pulled a number off the top of her head. If I were doing this in the classroom, that's what I would do. I just pick one within reason for the scenario. Okay, but guys, it's straight out substitution. You're just plugging the number in. And then what I would do is plug it into my calculator. I'm not going to do those calculations by hand. So I would type into my calculator 332.7 plus 4.139 times my value of 50 that was given to me, and enter. And I get 539.65. 539.65. Now again, on the test, it may ask you to round. So if this one would round to a whole number, would be 540 feet. It doesn't specify here, but I know that typically on the final it does specify. So just watch your rounding. So my answer in this scenario would be that the average height of a building with 50 stories is approximately 540 feet. Guys, don't overthink it. It's not supposed to be hard.
I am still getting a different answer in the calculator.
Did you type it in just like I did?
Yes.
Or are you trying to do order of operations? If you're trying to do order of operations, you have to multiply 4.139 times 50 first, and then add the 332.7. And then the other thing I would say is to check the mode of your calculator. Are you in radians or degrees?
I think it's just a regular calculator on my computer. Okay, well, I got the right answer now.
Okay, if you're just doing, if it's a basic 4-function calculator, you need to make sure it's following order of operations. Okay, I would anticipate if it's on the computer that it is, but in terms of order of operations, remember you always multiply or divide first and then add or subtract. So you would do this multiplication. If I were doing it, if I were going to walk it through myself, I would do 4.139 times the 50, do the multiplication first, get the answer, and then add the 332.7. I still get 539. Okay, so just be careful, but it's basic algebra calculations, basic math operations. So don't get yourself caught up in that. Okay, then question 90 says, using the coefficient of determination, is average temperature a good predictor? And I've got this should say, is the number of stories a good predictor for the height? This was a copy and paste error. Okay. So to get the coefficient of determination, and on the test, it actually just asks you what is the coefficient of determination. Okay. So we get that from Minitab. Again, that same command, stat, regression, fit regression model. It gives you lots of information. It gives you the p-value, it gives you the regression equation, and it's going to give you the R squared. Okay, under the model summary, now guys, you need to be careful because you'll see R-SQ, and there's 3 of them. You want the first one. The one with ADJ means it's been adjusted, and the predicted PRED is predicted. I don't care about either of those. I just want plain old R-SQ, R squared. It's stated as a percentage. So R squared in this scenario is 82.7. Okay, so I'm going to write that down. Now, to answer this question about is it appropriate, is it okay to use the number of stories to predict the height of a building? Because of the time constraint, we usually don't get too much into this, and I'll let you do it kind of waving your hand. So if R squared is greater than 50%, we say yes. If it's less than 50%, we say no. But mainly you need to know that R squared is 82.7%, and you need to know how to interpret it, which is question 91. And this one is a formulaic way to write it because you write it this way every time. And I have to remember. Okay, approximately 82.7% of the variation in the height of a building is determined by the variation in the number of stories. Now, pieces of that change. This 82.7% is going to change from problem to problem. That's your R square value. Height of the building, this first variable is always the Y, and the second variable is always the X. All the other words remain the same. And if you do not write the word variation, which Miss Ralston has capitalized, which means it's an important word, if you do not put the word variation in here, it is wrong. And it's multiple choice. And I know that there's one in there that doesn't have the word variation. You have to choose the one with the word variation in it. But it's written that way every time. Approximately R squared percent of the variation in the Y variable is determined by the variation in the X variable. Every time, all the time. Questions before I go back into a t-test? And I got to check the chat because I saw somebody put stuff in chat, but I can't see it in the share mode.
Ms. Rawson, I have a question. So
Ma'am.
some of the ones I got wrong on the homework, I was converting it to a decimal like the lady did on the examples. We don't do that.
Converting what?
I saw where she converted the R square every time to like a decimal and then square rooted it.
Well, you really don't, because we are now using Minitab, you really don't have to do that. Okay. In the previous software that we used, it did not provide R. So what the instructor was doing is they were taking R squared, writing it as a decimal, and then taking the square root to ultimately get R. Okay, but Minitab is doing all that work for you. So you're a little bit better off than previous students who had to do this calculation.
Okay, so is the R and the R squared, is that the same?
They're not the same. I mean, you've got R, and then R squared would be that value multiplied times itself. This is called your R is called your correlation coefficient, which is going to determine the strength and the direction of the relationship. R squared is called the coefficient of determination. It's not the same thing, and it's not going to be the same value. Now, R squared, the other thing that a couple of people were making mistakes on is that R squared should always be positive. even if your correlation coefficient is negative, because the relationship is negative, when you square a negative times a negative is a positive. So R squared is always positive. Your coefficient of determination should always be positive. And the coefficient of determination ultimately comes to this conclusion that you see here, but it also lets you know, is it appropriate to use, in this case, the number of stories to predict the height of the building? Well, 83% of the time, 83% of, so sort of, to make it easier to understand, 83% of the height of the building is determined or controlled by the number of stories. So there's about 17% of something else going on. Like, how high is each story? Is it the standard 8 foot, or have they gone to 10 foot or 12 foot? Because that can make a difference in the height of the building. So there's about 17% of something else going on, but I don't know what that is. But 82%, 82.7%, 83%, that's pretty good. So it's appropriate to use the number of stories to predict the height of a building. Other questions?
Yes, Ms. Ralston, you're saying, I know it's in the course too, about R being greater than how many degrees? I mean, how much percent?
It's R squared
R
is greater than 50%, then we're using, that's kind of the general rule of thumb that we're using, because we don't have time to learn the other statistical test to decide for sure. So we just kind of wave our hands a little bit here towards the end because we've run out of time, and we use R squared is 50% to decide whether or not, if it's greater than 50%, we say yes, it's a good predictor. If it's less than 50%, we say no, it's not a good predictor. And that's always R squared, not R.
Thank you.
Other questions? All right, let me stop the share a minute, and I got to go out and do a t-test for Farunja, but I can't see the chat when I'm in there. Where is the linear correlation on this question? Where's the R value? Is that what you're asking about, Farunja? On this question, the R value is question 85 that we got off of the scatter plot in Minitab. Okay, if we go back, when we did stat, basic statistics, correlation, and you got this scatter plot, and right underneath the scatter plot, we got, it says R equals 0.909. And so I copied that from Minitab onto my paper, which was question 85. All right, let me go back up to the t-test, because that was the other question. I think it was Farunji asked. Now, the one sample t-test, both of the examples on this review sheet have the raw data. It's okay. It works. Minitab will do the work for us. So I'm right above question 49 for the scenario. And it says Environmental Protection Agency standards require that the amount of lead in drinking water be less than 15 micrograms per liter. 12 samples of water from a local source have the following concentrations in units of micrograms per liter. And they give you what's called the raw data. They give you the list of 12 data values, which I'm writing down at the moment. So give me just a second because we'll need them when we go to Minitab. It's the same thing you would have to do when you're taking the final. Is I would have myself some scratch paper and write it down. Double check yourself. Make sure you write the numbers down correctly. And it says conduct a hypothesis test at the 1% level of significance to determine whether you can conclude that the mean concentration of lead is less than 15 micrograms per liter. Again, in making the decision to do the one mean t-test, the biggest thing is nowhere in this paragraph did I see the population standard deviation. So the fact that I do not have the population standard deviation is the big red flag to me that I'm going to do a t-test. Then, as we begin any hypothesis test, we state our hypotheses. Again, you want to look for words like claim, believe, think. And I've stopped sharing my screen, hadn't I? Y'all didn't remind me. Okay, I got it now, Ferungi. And somebody says, can I go over question 73? I'll get to 73 in just a minute, Tanya. Okay, so in this problem, looking for my hypothesis, again, the last sentence, conduct a hypothesis test to determine whether you conclude that the mean concentration of lead is less than 12 micrograms per liter. Okay, so it says is less than, which again, I hope makes you think of the mass symbol that looks like this. Again, because it's less than, this is the alternative. So we're going to say the mean is less than 15 micrograms per liter. Since the alternative is less than, the null will be greater than or equal to 15. Now, it asks you to identify the information, but you didn't get as much information in this problem, but Minitab will do it for you, okay? My population mean is 15. It comes from the hypothesis. Okay, I don't know the sample standard deviation because I have the raw data. Okay, so this is not given, but Minitab will calculate. Same thing with the sample mean. I have the raw data. So the sample mean's not given, but when I give Minitab or tell Minitab the raw data, it's going to calculate that for me. It did tell me that I had 12 data values, and it tells me to use 1% level of significance. So now I need to go out to Minitab. Again, it asks me if it's one-tailed or two-tailed. Again, this is a one-tail because it's a less than. And we need to calculate the T, test statistic, not Z. To do questions 53 and 54, we use Minitab. So I'm going out to Minitab, and I'm going to get me a clean sheet. And I have to enter the data that was given to me. So on my clean sheet, I'm going to enter the lead concentrations, okay, that I was given, 11.5, 13.7, 11.3, 14.2, 15.6, 8.1, 12.8, 8.9, whoops, what you typing, 10.3, 17.7, 9.3, and 15.8. Okay, so I've entered the 12 data values that I was given. And now I'm ready to do my hypothesis test. Minitab is going to do everything else I need it to do behind the scenes. So we go to Stat, Basic Statistics, 1 sample T. 1 sample T. In this case, I do have my sample in a column. I don't have the summarized data. I have the raw data. So I have to tell it, here's the data, so it can do all of the work behind the scenes. I am performing a hypothesis test. My hypothesized mean was 15. I choose options. It was a 1% significance level, so we have a 99% confidence, and we want it to be less than. And I click OK and OK, and Minitab does all of the work. Now, if you want it, look right here, the descriptive statistics. Here's the mean, here's the standard deviation. I don't necessarily need it anymore. What I do need is the T value, my T test statistic, and the P value. So T is negative 3.05 and P is 0.006. Guys, I hear my husband gathering up the garbage, so he's probably going to come in here in a minute to empty the trash can here in my office. So you might see somebody walk behind me. All right, so I'm going to write it down. My T test statistic that comes from Minitab, the T is negative 3.05. P is 0.006. Comes from Minitab. Then we have to make a decision. To make the decision, P compared to alpha. P is 0.006. Alpha is 0.01. Again, the easiest thing to do there, guys, is digit for digit. So first digit after the decimal, 0 to 0. Second digit, 0 to 1. 0 is less than 1. So P is less than or equal to alpha. When P is less than or equal to alpha, we reject the null. So if we reject the null in the context of this problem, that means the null is false and the alternative is true. So the mean is less than 15. So when I go to write my conclusion, even with the T, it's very similar to the Z. We start with our significance level. So we say at the 1% level of significance, and then again, you have to state it in terms of the hypothesis that is true. The one that was true is that it is less than, so I can basically use the sentence that I have highlighted in yellow. The mean concentration of lead is less than 15 micrograms, per liter. Okay. Any questions on that one? And then I'm going to go to question 23 for Tanya.
Can you scroll up a little 1 second before you go to the next question?
Okay.
Keep going a little bit further up. Okay, thank you. Okay, you can move on.
Okay. Question 73. Okay, to get to 73, I got to back up just a little bit, okay, to the question above 71. I got to get there first. Okay, so this particular question is a chi-square goodness of fit. And it says, Bayer, who makes Flintstones children's vitamins, claims that their vitamins are mixed so that each batch of vitamins has exactly the following percentages of color of the vitamins. So 20% are green, 40% are yellow, 10% are purple, and 30% are orange. To test the claim, bottles of vitamins were pulled and the colors of vitamins counted, and the results are listed in the table. Okay, so then they give you the table. Now, again, one of your challenges may be recognizing, oh, this is chi-square goodness of fit. Chi-square goodness of fit is the only test that we talked about where you can use qualitative data. And this is qualitative because it's talking about the colors, which are words, green, yellow, purple, and orange. And so then it says, state the hypotheses. And again, there's a variety of ways to state these hypotheses. I would probably say the distribution of colors follows the percentages stated by Bayer. Okay, so Bayer's saying they have 20% green, 40% yellow, 10% purple, and 30% orange. And so we're saying that the results that we got follow or equals the percentages that are stated. The alternative then would be the distribution of colors does not follow the percentages stated by Bayer. And again, that phrase implies not equal. Notice in the null, we still have equal, and in the alternative, we have not equal. And I'm writing down the numbers of each color vitamin. Then in the next piece, they ask you about the observed values and the expected values. Guys, the observed, notice in this table, it clearly says color and observed. And then it asks you in question 72 to fill in this table. But guys, Minitab's going to do that for me. I just have to put the data into Minitab. So I'm going out to Minitab to do that, which is then going to also get us the answer to question 73, which is what Tanya asked me about to start with. Again, I'm going to get a new sheet, hopefully not to confuse you. Okay, so in column 1, I'm going to put the color of the vitamin, and we have green, yellow, purple, orange. In the second column, I'm going to put the observed value, which is the values that are given to me in the table in the question. There were 1,149 green, 1,948 yellow, 552 purple, and 1,401 orange. Now, this one is specified or specific proportions because they've told us we should have 20% green, 40% yellow, 10% purple, and 30% orange. So I have to have a third column here with the expected percentage. And you're going to enter that as a decimal. So green, we expected 20%. Yellow was 40%. Purple is 10%. And orange is 30%. So you have 3 columns. You have the color of the vitamin, which are your categories. You have the observed values, which are given in the question. And then you have your expected percentages, which are given in the question, written as a decimal. Then I'm going to stat, tables, chi-square goodness of fit, one variable. Stat, tables, chi-square goodness of fit, one variable. Then it asks me, where are your observed counts? They are in column 2. Where are your categories? They are in column 1. Which type test are you doing? Are you doing equal proportions? Or I like to use proportions specified by historical counts because it allows me to go ahead and choose those expected percentages. Okay, so you select the observed value, which we have in column 2, the category name, which is in column 1, and then we use proportions specified by historical counts, and we enter the expected percentage column. And then I'm going to click OK. Now, should you be asked on the final, and in some cases you are, what the expected values are? Okay. Minitab has calculated those for me. In this very top table on the results, observed and expected counts. It has the category, it has the observed, it has the proportion that I told it, and then it has calculated the expected. We would have expected 1,010 green, 2,020 yellow, 505 purple, and 1,515. So there are your expected values. Minitab has done that for you. We could copy those onto the table there on question 72. Question 73, which is the one that Tanya asked me about, on this printout, you have the observed and expected accounts, and then you have the header chi-square goodness of, it just says chi-square test, it doesn't say goodness of fit. So my chi-square is 34.6485, and the p-value is 0. Okay, on this printout, you have the table, and directly underneath it, you have the header chi-square test, and you can find your chi-square and your p-value. Okay, so maybe it's this symbol that's throwing you off. That's this notation for chi-square goodness of fit. That's the symbol. The chi is the Greek letter that looks like an X. And then GOF stands for goodness of fit. So I write it usually like this: chi-square goodness of fit is 34.6485. The p-value is 0.000. What did they tell us to do? Did they give us an alpha? Okay, they didn't give us an alpha here. The standard is, if you're not given one, to use 0.05%. So if we compare P, which is 0, to alpha, which we're going to use 0.05, again, comparing it digit for digit, 0 compared to 0, 0 compared to 5. 0 is less than 5, so P is less than or equal to alpha. When P is less than or equal to alpha, we reject the null. Again, if you reject the null, remember that means the null is false and the alternative is true. And you should always write your conclusion in terms of the true statement. So we would say in our conclusion, if I've got enough space to put it in there, at the 0.05 significance level, the Flintstone, I spelled that wrong. Oh, good grief. Can't spell Flintstones. We could just use the statement I had earlier. The distribution of colors of Flintstone vitamins does not follow the stated or given distribution or given percentages. Again, there's lots of different ways to word it, but you basically got to end up saying that it doesn't follow it, because that's what we've proved. Now, I saw a couple of you putting things in chat, so give me just a minute, because I can't see it when I'm in this share screen mode. Yes, Tanya, I'm going to post the recording after. It'll take it a little while to process, especially since it's like an hour and 40, almost 45 minutes. It'll take it a little bit to process, but once it's processed, yes, I'll post it. And Farunja, yes, if you're not given an alpha, we tend to use 0.05. That's just a general rule of thumb within the world of statistics. Okay, other questions? I think we've hit everything for the most part except ANOVA and the confidence intervals, but you guys must be comfortable with those.
Could you go over one of those?
One of what?
Like confidence interval?
You want a Z or a T?
T.
Okay, I've got a T. All right, again, looking at my review sheet, I'm going to scroll down to question 17. It says, a recent study of 25 students showed that they spent an average of $18.53 for gasoline per week. The sample standard deviation of the sample was $3. Construct a 99% confidence interval for the mean amount students spend on gasoline per week. All right, the phrase that I just highlighted, the sample standard deviation of the sample was $3, is my clue that I'm going to do a T interval, because we use T whenever we know the sample standard deviation. And then it starts asking me some questions, and these first four are all given to you in the problem. It says, what is the sample mean? Well, the first sentence says a recent study they spent on average $18.53. So my sample mean is $18.53. We sampled 25 students. My sample standard deviation is $3. That's highlighted in yellow. And it wants me to construct a 99% confidence interval. All of that information is given within those three sentences. Then I'm going out to Minitab. And I want to do a one sample T interval. So it's stat, basic statistics, one sample T. It's the same command we use for a hypothesis test. I have the summarized data. My sample size was 25. My sample mean was $18.53. My standard deviation was $3. I am not performing a hypothesis test. Under options, I want a 99% confidence level, and we always use not equal. Okay, okay. And I need these numbers under the label 99% CI for mu. And so we have 16.852 and 20.2008 or 28. Yeah, whatever. Okay, so the lower bound is the first number in that parentheses, which is 16.852. The upper bound is 20.20 with an 8. The error bound margin you have to calculate for yourself. The error bound margin is the upper bound minus the lower bound divided by 2. It's one of the few manual calculations you have to do in this course. So I would do 20.28 with 8 on the end minus 16.852 all divided by 2. And if I'm doing this on my calculator, guys, you have to do the subtraction in the numerator first. That's why there's parentheses around it. So we do 20.208 minus 16.852. We enter. Let me move this. We get 3.356, and then we divide by 2. So we end up with 1.678. So my error-bound margin is 1.678. We had 3.356 divided by 2. Then you write the conclusion. And again, this is one of those conclusions that's pretty standard. It's kind of a formulaic statement. We say, with 99% confidence, the true population mean amount students spend on gas per week is between $16, I would probably say $16.85, and 2021, round it to 2 places because that's how we normally would state money. But when you're stating the conclusion of a hypothesis test, the percentage for your confidence level could change. The explanation for what the mean is, what is the variable? We're talking about the amount students spend on gas per week is between, and you give your lower bound and your upper bound. The other phrase here, yeah, it is a phrase that's important is that you say the true population mean. And again, I saw some of you putting things in chat. So let me see if I can get it to pop up. It may not. Maybe it will. Well, maybe. I have to stop the share. It won't let me get to it. Leanne, there's 2 different things that we're doing. We're doing confidence intervals, and you can either do a Z or a T, and you have hypothesis test for a Z or T. And the reasoning behind which one you do, Farinja, I'll go back through the menu tab in just a minute. Let me go over here to a piece of paper. Okay, the first part of, let me share my screen again. The first part of Module 3, we talked about confidence intervals, which give you a range of values for the population mean. You do a Z interval if you know the population standard deviation. But in the example that I just did for the T interval, we know the sample standard deviation. The difference or the deciding factor is whether the standard deviation that has been given to you is the population standard deviation or the sample standard deviation. Occasionally, you get both. Guys, if you know the population standard deviation, you got to use it. If you know the population standard deviation, you got to use it. Now, this same pattern holds true when you're thinking about one mean hypothesis test, which also was covered in the second half of Module 3. And again, there are two of those. You either have a z-test or you have a t-test. We do the z-test if we know the population standard deviation. We do a t-test when we know the sample standard deviation. So it's the same guidelines. It comes down to what standard deviation do you have? Do you have the population standard deviation or do you have the sample standard deviation? Okay, Farinja, I'm going back through the keystrokes again. Stat, basic statistics, one sample T, because we were doing a T interval. It originally comes up as one or more samples. I don't have the raw data. I have summarized data. I enter the sample size given in the problem, the sample mean given in the problem, and the standard deviation given in the problem. I have to choose options to indicate the confidence level, whether it's 95 or 99 that's given in the problem. I click OK and OK, and it gives me the results. Okay, other questions? Okay, it is almost a 2-hour long recording, so it may take a little bit for it to process, but as soon as it processes and I'm able to upload it to YouTube, I'll post it in the announcement so that you'll have it to review should you choose to do so as you're preparing for the final. Remember that discussion 4 is due by tonight. Your homework on correlation and regression is due by tonight at 11:30 p.m. The final exam opens on Tuesday, and I would encourage you to take it sooner rather than later so you don't have to run the risk of losing access to Minitab. Any other questions?
Thank you so much, Ms. Ralston.
You're very welcome. Y'all have a good evening.
Thank you, you too.
Thank you.
Thank you. Have a good night.
You're welcome. Thank you.